Have you ever done something that you wish you could undo? Well, in maths it can be done with inverse functions. So functions like squaring and taking the square root will undo one another. So they're inverse functions. And inverse functions are written with this notation of f to the negative 1 of x. So if our function is the square root of x, then our inverse function is x squared. And note that f to the negative 1 does not mean 1 over f of x as it would if it was a to the negative 1. If we start with x and we apply a function and then apply the inverse, we've undone the function, so we're back at x again. And it doesn't matter which order we do those two functions, we'll end up back at x again. Sometimes we need to restrict the domain of a function for its inverse to exist. For example, if we were considering f of x to be x squared, then both positive 2 and negative 2 squared will give you a positive 4. So going backwards, the inverse function of 4 could be either positive 2 or negative 2. And for a function to exist, we can only have one value of y, so we would need to restrict the function there. With our f of x equals x squared function, we can restrict the domain to positive or negative values only so that our inverse function exists. So if x is positive in our x squared function, then when we do the inverse, we want to take the positive square root. We use the sign square root there to mean the positive square root only. If our domain for our x squared function is negative, then the inverse function is the negative square root of x. Graphing those two functions, we'll start with y equals x squared, which we have done in previous videos. And now looking at the square root of x, then we can plot some points. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So there's another point there. We can join those points up into a smooth curve like that. You'll observe that those two are symmetrical. They're mirror images of one another about the line y equals x. This means that x and y change places in the two functions. To find the inverse of a function, then what we need to do is just interchange the x's and the y's. So for example, if we have the function f of x equals the square root of x minus 3, we can find the inverse function by interchanging the y and the x. First, we need to observe what values of x are possible in our function. Now, for our square root to exist, we have to have x is greater than or equal to 3. So our domain of f of x is greater than or equal to 3. And then taking the positive square root means that y could be 0 or above only. So we'll write the function as y equals instead of f of x equals, and then we can interchange the x and y. We'll swap roles there. And we're trying to make y the subject, so we'll square both sides and then put y by itself. So we'll end up with y equals x squared plus 3. Thus the inverse function of our f of x is x squared plus 3. Its domain is x is greater than or equal to 0, and that is the same as the range of the original function. And the range of the inverse function is the same as the domain of the original function. Let's plot those two. Once again, we can start off with the familiar graph of x squared plus 3. So that's a parabola with a y-intercept of 3. And then we can use the fact that the inverse function is going to be a reflection of that graph in the line y equals x. So this point here, our y-intercept becomes our x-intercept there, and our graph will look like that. So we've seen that inverse functions undo one another, and that graphs of inverse functions are mirror images about the line y equals x. And to find the inverse of a function, we interchange the x and y variables.